So now we're back to learning GDScript from zero, and this is an open source project by GDQuest.com. All right, so let's continue from where we left off over here at Introduction to While Loops. All right. So we've seen that we can use functions to reuse code. In this lesson, we're going to learn about loops. Loops help us repeat code. To illustrate how loops work, we're going to take a game board split into a grid, right? Something like this right here. Actually, it is that. Our robot can move to a neighboring cell by changing a vector2 variable named cell. It represents the current cell the robot's in. We can, when we increase cell.x, the robot moves to the right. True. Note that we delay the robot's movement in the app, or they're delaying it in the app to help us visualize how it moves. The following code would normally move instantly. Yeah, true. So yeah, when we put move to the right, it goes 1, 2, but it would just, it would just totally not do any of that. It would just go straight to 2 if this was a regular function call. All right, so let's go down to the next thing. So we can move diagonally by adding a vector2 directly. All right. So yeah, we've got func move to end, and then we've got vector2 1 1 and vector2 1 1 again, and it'll go 1 1 1 1 like that, and boom boom, just like that. All right, so the above code works for a predefined board with the size of vector2 3 3, but the move to end function wouldn't work if the size of the board was different. True, because it would only go to here, and if there was another one right here, it wouldn't go down one. If there was a whole, if it was a whole number set of cells, it would just stop right in this one, and it wouldn't go here because that's what we told it to do. Regardless, so the robot would either stop before the end or go too far, right? So yeah, it would stop before the end in this case if it was if we added a whole new one. That being said, to implement a general solution for all board sizes, we can repeat the robot's movement until it gets to the end. True. So for code that repeats, we can use loops. Pardon me. So using while loops to repeat code, all right? So we can use a while loop to make the computer repeat a code block until we meet a specific condition or decide to break from the loop. Yeah, look, I'm trying to get through these, honestly. I want to start making freaking videos. I'm not videos, but games, right? So let's stop with the freaking trying too hard. So here's how we use a while loop. So we got var number equals 0, while number is less than 4, we're going to print a number, and then number plus equal 1, right? So it's going to go through once. It's going to check if it's less than 4, which it's 0, so it's good. It prints 0, and then number plus equals 1. So it goes through again. It looks, and now the number's 1. It's still less than 4, and it just keeps going until 3. Once it changes it to 4, once it says plus equals, once this is 3, and says here one more 4, it looks at this. This is 4 now. 4 is not less than 4, and it stops the program, right? We'll see that right here in just a second. We use the variable number to keep track of how many loops the while loop completes. Each time we go through the while loop, we add 1 to the number, right? The while loop keeps running for as long as the condition is true. In this case, it keeps running while, number is less than 4. We can see the following code is executed 4 times in the console. True. So let's do the steps, all right? So there it is. It's running the function. Var is 0 now. We see the number is 0 down here. While this is less than 4, okay? Print number. So it prints 0. Now number's 1, all right? Because we just added to it. We go the next time through the while loop, all right? It's 1, it's less than 4. Print it out. Same here. 2, print it out. 3, we got that there. Add 1 to it, and then we press step again, and it just ends it because this is not less than 4. This is not less than 4. Just like that. All right, let's reset it. All right. So let's apply this to our move to end function. This time we're going to compare the number of loops to the board's width. True. We go through the loop until we reach the width of the board. True. Okay. So note that we move the robot until its position is 1 less than the board's width because we're counting tiles from 0. Also true. Yeah, we're going to have to do -1 on a lot of these. A board of 3 by 3 cells would have cell coordinates going from 0 to 2 on both the X and Y axes, right? So we've got func move to the end. We've got while cell.x is less than board size.x -1. We're going to say cell.x plus equals 1, right? So, like right here, we've got it to the end like that, and it just stops. Or we could make it 9 big, and we could just go pop, 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 and it'll just keep running until it hits this last one, which is board size. It's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 8 right there, right? Exactly. Well, let's go to the next thing. While loops can cause issues. Absolutely. If we're not careful, our while loop can run infinitely. In that case, the application will freeze. So let's take a look at this code example. We've got var number equals 0 while number is less than 10, draw a square. Okay. So if we don't have a number plus equals 1, it's always going to be 0 and it's going to draw squares forever. So what would happen if the computer tried to run the code above? This one right here, 20 squares? No. It would draw squares infinitely until the program is terminated. I think so. 10 squares. Yeah, no, that was it. No, actually, it's still the middle one. Let's go. Submit it. There we go. All right. So we're right. Because we don't increment number within the while loop, it always stays at 0. True. As a result, the number is always lower than 10, so we never break out of the loop. Also true. Since there's no way to exit the while loop, the computer will attempt to draw squares infinitely, which will freeze the program. Yes. So when programs stop responding on our computer, it's often due to an infinite loop, turns out. All right. So when to use while loops, all right? So at first, we will not need while loops very often. True. Usually we use for loops. Even the code we show here has more efficient alternatives. True. Also, there's a safer kind of loop, the for loop, which we'll look at in the next lesson. This is the main loop right here, the for loop. But the for loop's made out of while loops, so we learn while first. Anyway, yet while loops have important intermediate to advanced level uses. Yes. So we at least need to know what they exist and how to use them. Yes. So we use while loops every time we need to loop an unknown number of times. Okay. For example, games run in a loop that typically generates 60 images per second until the user closes the game. This is possible thanks to while loops. Yes. There are other good uses for while loops. Reading and processing a file, like a text document, line by line. Yes. Yes. I'm thinking about it though. Anyway, processing a constant stream of data, like someone recording audio with a microphone. I would say yes. While something's true, keep recording. And then once you make it false, it stops recording, right? Reading code and converting it into instructions the computer understands. Yes. Various intermediate to advanced level algorithms, like finding paths around a map for AI. Okay, maybe. We'll have to figure that stuff out later. Let's practice some while loops. As they're useful to know, it's also an excellent opportunity to practice 2D vectors. Then we're going to move to the safer for loops in the following lesson. I'm thinking about Pokemon and how the sprite walks around the screen, and every time it hits it, you land on a square, there's like a chance that you might there's like a random thing, a math.random saying maybe you're going to run into a Pokemon in this square, and if not, you just go to the next one. Anyway, let's go. Practices. Moving to the end of a board. We're going to use a while loop to have our robot move from the top of the board to the bottom. All right, let's practice. So our goal is our robot has decided to stand at the top of the board. Yeah, there it is right there. We're going to complete the move to bottom function so the robot moves to the bottom of the board. The board size is determined by the vector 2 board size. The robot's current cell is vector 2, 0. We're going to make sure to use the while loop so the function works for any board size. All right. So let's change this pass into a while to start with. While. And it's going to be something about the board size. While, let's say position. Position.y is less than board size.y. .y. Okay. I think that's a good way since we're moving y's. Is that good though? If cell.y, is it called cell? Hold on. Look at this. We got cell. Okay, cell. Cell is a vector. Okay, so while cell.y is less than that, we'll say cell.y plus equals 1. Let's see if this works. No. Wait, what? Oh. Y minus 1. Look, he went past. Let's say minus y minus 1. Board dot size y minus 1. Board size dot y minus 1. How about that? Let's do it. Run it. All right, goes. There it is. Awesome. Great. And continue. All right. And lesson complete and continue. There we go. All right. So now we're on to introduction to for loops. And we'll see you next time.